So here's my tutorial about a neutralization reaction and finding the pH. So if we had 5 of these, all the OHs would come off, and 3 of those, all the H pluses would come off. Then 3 of these would meet up with 3 of those. They would neutralize each other to water, and we would have 2 OH minuses left over. And then we could figure out the molarity and then the pH. So I've already started this one. Let's do it for real though. Molarity is moles per liter. Liters is on the bottom inside here. So when I multiply by liters, I get moles. The liters cancel out from the liters at the bottom inside here. So here's the molarity times the liters. It gives me moles. Now, to be super picky, it's moles of HCl, but we know this all comes apart. So the moles of this is the moles of H plus that would come off. So when I find this moles, it is also the moles of H plus that come off. I can do the same thing for NaOH. And I take the molarity times liters. The liters inside here on the bottom cancel out and gives me moles. Technically speaking, it's moles of NaOH, but we know this is a strong base. So all the OHs come off. And so that is also the moles of OH minus that would come off. So these will meet up and they will neutralize each other. So the thing that remains will be the one that had the most, because I know also that what we've got here is OH minus plus H plus makes water. So the ratio is 1 to 1. So it's not 2 to 1 or something that I got to compensate for. One of these, we eat one of those. One of those, we eat one of those. So what will remain? The one that has the most. So you just do big minus small. So we'll do 0.06875 minus 0.06, which leaves 0.00875. And what is that? It's moles, and this is something to be careful of which one? Because it's easy to look up here and say, oh, I subtract top down, I must have H plus remaining, but no, we're doing big minus small. What we have is OH minus remaining here. But for pH, what I need is molarity, so I need to divide this by the liters. The liters, remember, is the new liters. It is 120 milliliters plus 275, so this is 395, right? 395 milliliters now that I've put these together. So that is 0.395 liters. And I'll subtract out 0.06 and divide by 0.395. And my molarity is 0.0222, if I round to the third decimal point. That's interesting. Anyway, and what is that? That is the molarity now of OH minus. Negative log of that answer will be POH. Don't get that wrong. Everybody's done it, including me in front of a room full of kids. If you're going to use OH minus molarity, you're going to get POH. So negative log of that answer is 1.65, good enough. And then 14 minus that answer will give you pH. 12.35, good enough. It's probably way too precise and probably violated significant figures, but we'll live with it.